Okay.
Okay. So part 1 of your lab sheet, lab 4.2, 4.3, says water is polar, oil is nonpolar. So what does polar mean and what does nonpolar mean? So the first thing we want to do is draw a water molecule below and label it. So we ran through this really fast at the end of class last week. If we draw a molecule of water, what would we expect to see? Chris?
One oxygen and 2 hydrogen atoms.
Okay, so 1 oxygen chemically bonded to 2 hydrogens. Hydrogen's are little, oxygen is big. I'll just put an H in the hydrogen because I can't fit the word hydrogen. So I have 1 oxygen chemically bonded to 2 hydrogens. The chemical formula of water is H2O. I actually think that is literally a test question. What is the chemical formula of water? So H2O, make sure you know that. The chemical formula of water, H2O. They have 1 oxygen chemically bonded to 2 hydrogens. Now, we know that there's a lot more to it than that. Last week we talked about how chemical bonds are what? Electrons. So the oxygen and the hydrogen are sharing a pair of electrons. The bond here, this little stick, is a shared pair of electrons. Electrons are tiny little pieces of atoms that are negatively charged. A tiny piece of an atom that's negatively charged is an electron. When 2 atoms share electrons, they have a chemical bond between them. So we have 2 bonds, of course. The oxygen bonds with this hydrogen and it also bonds with that hydrogen. So we have 2 bonds. 2 shared pairs of electrons holding that molecule together. We also know that water is polar, and what that means is, can somebody tell me?
There's an imbalance in the share of electrons.
Imbalance in the share of electrons. So do you know which, the oxygen or the hydrogen, has more than its share of electrons?
Oxygen.
Oxygen. So oxygen is an electron hog. It loves electrons. It is much stronger. It has a stronger ability to attract electrons. Electrons are negatively charged. So the oxygen end of the water molecule develops a partial negative charge. It hogs those negative electrons, and so we end up with this little Greek delta, means partial negative charge. Then, of course, this end of the molecule where the hydrogens are develops a partial positive charge because electrons are negative. When they don't get enough of the electrons, then all that's left is the positive part of the hydrogen atoms, so they get a little partial. Now, the oxygen doesn't completely steal the electrons away. It's still sharing them. It's just sharing them unevenly. Like, I get the electrons 6 days of the week, and you get it the other day. But they're still sharing, just unevenly. So you get a polar molecule, which means there's a partial charge at one end that is negative and a partial charge at the other end that's positive. This makes water have different properties than nonpolar molecules. So then, if you've got your drawing done with your oxygen bonded to the 2 hydrogens, a partial negative charge near the oxygen end, partial positive charge near the hydrogen end, then we're all set with that. The next line says chemical bonds are formed between hydrogen and oxygen because they share what? Electrons. Chemical bonds are formed because they share electrons. Alright, so the oxygen atom in a water molecule takes more than its fair share of electrons. So the oxygen end of the molecule has a partial what charge?
Negative charge.
Negative charge. Partial negative charge just because electrons are negative. If you have more electrons at one end and they're negative, then that end has a negative charge. So then that leaves the hydrogen end with less than its fair share of electrons, so that end gets a partial what charge? Positive charge. And because of this, we call water a what kind of molecule?
Polar.
Polar molecule. up some what? Static electricity. And static electricity is really just, what does the word static mean? Static? Is my hair going nuts? No. What does static mean?
Stays the same.
Okay, stationary, stays the same, doesn't move. Static means stationary, and electricity means, Duchesne, you've said this word like 16 times already today. What is it?
Electron.
Electrons, stationary electrons. So when you comb your hair, the comb picks up electrons.
Stationary.
Yes, electrons. Static electricity, stationary electrons. This comb is picking up electrons, and electrons have what kind of charge?
Positive.
Negative charge. When hair is combed, the comb picks up electrons, and electrons have a negative charge. When hair is combed, it picks up electrons, and electrons have a negative charge. So, what do you think happens when you bring two charges together? If I have a negatively charged comb, it will attract things that have what kind of charge?
Positive.
A positive charge. So, different charges attract each other. If you have two things that have the same charge, they repel each other. So if I had a negatively charged balloon on a string and this negatively charged comb, I could repel the balloon with the comb. They don't want to get near each other. But positive things are attracted by negative things. So if I brought my negatively charged comb full of electrons near an oxygen molecule, what do you think that oxygen molecule would do?
I'd point towards it, isn't it?
Yeah, it would like literally flip itself over to get the negative end, where the oxygen is, as far away from the negative end as possible, and the positive end, where the hydrogens are, as close to the negative end as possible. So that molecule would just turn, so the positive end pointed toward the negative comb, and the negative end pointed away from the negative comb. So the next sentence says, the what end of the water molecule is attracted to that charge on the comb? The positive end of the water molecule is attracted to the negative charge on the comb. So now, if we pass out, I'm going to try to poke tiny holes, and I'm going to try to give people enough waste beakers that we don't make a colossal mess. But we all know about colossal mess in this class. So now would be probably a good moment to put away anything you like. So we'll have to have two groups at a time sharing one of these big guys, so kind of draw yourself together. For this. So I'm going to assume that you would make very tiny people who can possibly express it so that you're not making diagrams.
I think you should probably go down.
But if you do, it's just water.
Make it to 5, and that would be...
We're not going to go huge.
Mm.
Just move all your stuff so we don't get it back. Alright, so here's the basic goal of what we're going to do. You're going to record your observations of a stream of water that is brought near a slightly charged comb. So you really want to keep your comb dry even if you spill everything. Dry combs hold electric charge, and wet combs really, really don't. Wet hair also really doesn't produce a lot of static electricity. So a slightly charged comb is just going to have a few passes through your hair. The more you do, the more electrons you're going to pick up. If you have trouble with this experiment, sometimes it helps if you take your shoes off, because sometimes you develop a kind of net charge over time, and if you have rubber-soled shoes, you you don't discharge, so you just keep getting positive, and then the electrons kind of flow out. Yeah. This experiment tends to work okay. Other experiments we do, you really do have to take your shoes off. But I'm just saying, you're probably fine, but if you see trouble, that could be it.
Are you joking or are you serious?
I'm serious.
Okay, I don't know if you're okay.
Yep, totally serious. I know that sounds strange. Okay, so poke like the tiniest hole in your cup, and then pass the nail down because I only have 2. Apparently we, like tiniest hole in your cup. But the hole, yeah, there. That should do. Alright, so poking holes, each left is a hole, and you pass the nail. Does everybody have a waste speaker? Nails along.
Hey, spaghetti. Smells like spaghetti.
If you have trouble with water and it's going through, or the tiniest hole you can get in your cup.
Where?
In the bottom of the cup,
Well,
so the water
next time
doesn't
when I'm singing that.
Okay. So if you want to plug the hole with your finger, it's just water, that's fine. So we'll give you some. And then you can always reclaim the water from your waste speaker. Alright, so write some observations of the stream of water that is brought near a slightly charged cone.
Is the camera still going? I'm pointing it towards you. Oh, we have 2. So you take the purple one. Don't take the blue one.
Yeah, go ahead and... What do you mean, if your stream of water is not constant stream, you need a bigger hole. Can you do it? Oh, thank you. I'm not doing anything useful at this point. Okay, so we're combing. Slightly charged the first time. Oh, here we go. So what is happening?
It's not moving towards it, is it?
Yeah.
Okay, here's it normally.
Well, will it move toward it or away from it? Try the fine edge of the comb. Sometimes it holds more electrons. Like if you hold the big fat teeth and comb, and then try it. That should do.
Alright, ready?
Now, bring it close. Oh, good.
Your hole might be crooked though.
Yeah, I think your hole is crooked. Crap. You just said that on camera. I'm going to tell you that. Oh, no. I said
I was so
something on
excited.
camera once, too.
How many passes?
Just 3 or 4 at first, and then we'll see.
Oh, hold it. Plug it. No, plug it.
Ooh.
Oh,
That
plug
worked better.
Really?
When he tipped it, it was going better. Yeah, don't let your comb get wet.
Okay, I don't think it's...
Yeah.
Here, what are you guys doing? Go ahead and try again. You may need a slightly bigger hole if you want to enlarge your hole. It looks like your comb is kind of wet.
Oh.
We'll have class-wide light
Ours is not bending.
spreading. Oh, gross.
Yeah, he's like...
We all know that. Here, make a stream of water again and see what happens. My hair is usually staticky.
Here, you want to...
Yeah, make it a little bigger. We'll see if that works. This works really well when I'm done.
Alright, still brushing.
I'll take my shoes.
Alright, make a big hole, pour in your water, and then...
I see it. You're moving towards it.
Okay, pour in the water, and then see what happens.
Oh, now there's crack. Whoa.
Okay.
Alright, now...
Tip the cup so you've got a perpendicular stream of water. Yep, that way.
Alright, so that's...
Oh no.
Alright, let's
I think it's naturally turned. Naturally turned on.
Oh, it is just working a little.
Yeah, it is.
It's
I
very
can't
slight.
see anything.
It's very,
You
very
keep
slight.
trying. I probably.
You're-
I've never had lights before. Anyone got any luck here?
trying to do.
Oh.
It's a piece of hair of yours. It's red. Get off the roof.
She forgot her lunchbox.
Oh. Well, sometimes you suffer because you're in class.
She's gonna get diseases on it.
Okay. So is the comb charged up? Ooh. Okay, dry your comb.
camera.
Not on Ryan at all. Here, I'll take the comb.
Thank you.
And your lab partner. Hello.
Ew, are you serious?
Yes.
He used my pen to get gum off of a book.
Ew. Hard.
Not even mine. Well, mine is hair.
Okay, so come really fast.
What do I do? Hold it.
Oh my god, look at that.
Okay, we're still filming. So comb, and then we'll see if we get.
Wait, you've got to comb.
Not my hair. You gotta comb. Come on, get that comb.
Combing. Okay, so now bring it near the top of the stream.
What is it supposed to have?
The stream of water should bend.
Ben? I think you
Which
need to
is-
take your shoes off. Take your
It
shoes
could be.
off.
Has anyone had any success here? We have
Yeah.
2 today. Oh, good. All right. We will observe Bethany's electrons. Are your shoes off?
Nope.
No? Okay.
Let's do something.
Come near the top of the stream. Now move away. Toward. Away. Beautiful. Okay.